Assalamu alaikum dear students. Hope you are fine. You are utilizing this time in a productive way. In the yesterday's video lecture, we did theorem 8.2 opposite sides of parallelogram are equal. Now we will do theorem 8.3. These theorems are mentioned in your textbook. I will read the statement, but I recommend you that keep the book view so that you can have the clear idea about the theorem. Theorem is if one pair of opposite sides of a quadrilateral or parallel and equal, then it is a parallelogram. If one pair of opposite sides of one pair of opposite sides of one pair of opposite sides of quadrilateral are parallel and equal. If one pair of opposite sides of quadrilateral are parallel and equal, then it is a parallelogram. This is the statement of the theorem. We are supposed to prove it. So it is a very simple. Here again the concept of congruence will come into effect. So concept of congruence is very important. You have to be this is your parallelogram A B C D. Sorry, this is quadrilateral, and we assume we will take one of the sides, say AB and DC, and we will write that AB parallel DC. This is given. Actually we have to prove that this is a parallelogram. Given is, let us write the given is a quadrilateral ABCD in which AB parallel DC and AB equals DC. AB parallel DC, AB equals DC, one pair. We are required to prove that this quadrilateral is a parallelogram. To prove ABCD is a parallelogram. How will you prove it? Very simple. Join AC, join proof, construction, join AC. Now we will write the proof. Proof is very simple. What is the approach? What we do, we will make this triangle congruent to this triangle, and we have to show that this is a parallelogram. What is parallelogram? A quadrilateral definition. First definition: a quadrilateral having opposite sides of whose opposite sides are parallel. First definition, recall that. Then it has the property that the opposite sides are equal, etc. That is the another case. But definition is a quadrilateral is a parallelogram if its opposite sides are parallel. This side is parallel to this side. It is given. Now, if we are able to prove that this side BC is parallel to AD, then we are through. We are this is the required state which we are supposed to find, that BC should be equals AD. Sorry, BC should be parallel to AD. So for that we will make these two triangles congruent. So let's make them congruent, but before that you pause the video to note it down. We will write in triangles ABC, ABC, ABC and DCA and CDA. Sorry, this is your C and CDA. AB equals DCY. AB equals DCY because by given. AC equals ACY. This is common. Angle Name this one angle 1. This side is angle 1 equals angle 2. Angle 1 equals angle 2y. Angle 1 equals angle 2y, because these are alternative interior angles. These are alternative interior angles. How? Look, AB parallel DC and AC is transversal. So this angle and this angle, these are alternative interior angles, because AB parallel DC and AC is transversal. So these, what type of angles these are? Angle 1 and angle 2. So these are alternative interior. So alternative interior. So alternative interior angles. Alternative interior angles. These are alternative interior angles. Now have a look. We have what, by what criteria that these two triangles are congruent? We can say that these are congruent. This is AB, this is AC, and included angle. This is again this is CD, this is and AC and included angle. By SAS we will write, by SAS triangle ABC is congruent triangle to CDA. Triangle ABC is congruent triangle to CDA. What happens when triangles are congruent? Remember the concept CPCT very well. Then corresponding parts are equal, corresponding sides are equal, corresponding angles are equal. So name this angle 3 and angle 4. Therefore we will write, therefore angle 3 equals angle 4. Angle 3 equals angle 4. Why? Not alternative, by alternative interior, because this is not parallel to this yet. We will write it by CPCT. This was not given. We cannot draw a conclusion as we did here. Why here angle 2 is equal to angle 1? We have only given that AB is parallel to CD. We are not given that BC is parallel to AD. Someone among you might thought that we will write it. These are alternative, but these are not equal yet. We don't have any proof. We don't have any reason to show, to say that these two are equal by alternative interior angles, because this is not parallel to this. This is the this is the required we are supposed to prove. So this angle is equal to this angle by only CPCT. Now we will write what type of these angles are, but these are alternative interior angles. So when alternative interior angles are equal, lines are parallel, but these are alternative interior angles. When alternative interior angles, if we consider, look, AD and BC and AC transversal, this angle and this angle are alternative interior angles. When alternative interior angles are equal, lines are parallel. Therefore AD parallel BC, AD parallel BC, AD parallel BC. This was the I will again repeat it. This angle is equal to this angle by CPCT, but these are alternative interior angles. When alternative interior angles are equal, lines are parallel. Angle 3 equals angle 4, so BC is parallel to AD. So AD is parallel to BC, and also it is given also AB is parallel to DC. This is given. This is given. So a quadrilateral, if its opposite sides are parallel, then it is a parallelogram. Therefore ABCD is a parallelogram. Therefore ABCD is a parallelogram. So a quadrilateral, we have another definition for the parallelogram. A quadrilateral having one pair of opposite sides parallel and equal. Remember this. So this is recall the very first lecture when I told you that we will modify the definition of a parallelogram. Parallelogram, we can define a quadrilateral having opposite sides parallel. Now by this theorem, we can also say that a quadrilateral having one pair of opposite side parallel and equal. A quadrilateral having one pair of opposite side parallel and equal. I hope you will get it. I will write it again, the definition, new definition, modified version, modified definition. A quadrilateral having one pair of opposite side parallel and equal. A quadrilateral having one pair of opposite side parallel and equal, it is a parallelogram. So this was all about theorem 8.3. In the subsequent video lectures we will do some more theorems. These are the very important theorem. These theorems are mentioned in your textbook, and later we will do some textual exercises. Thank you, class.